This will be a brief vignette. I've got 10 minutes or so to describe to you what I think is going to be not only the biggest revolution in the history of healthcare, but possibly the biggest social revolution in the history of humanity. Big claim, which we may discuss later, and how do I move the slides? Okay, so this is a quick summary of the narrative, and this first phrase is used more for the general public, well, the first and second ones, than it is for this audience. But this is a quote from Cohen and colleagues in the New England Journal of Medicine a few years ago, which says precision medicine will become possible because of huge data sets on large populations with millions, perhaps billions of characterizations of each person. Study populations will grow to millions, which will allow observational studies with novel statistical methods that allow discovery of useful reproducible patterns and relationships. Now, the thing to appreciate, that health is not a cost. Health is the largest, most important and fastest growing industry in the world for the simple reason that the increased discretionary income from advances in economic productivity in other areas of the economy inevitably translates into increased expenditure on lifestyle and health, with health ultimately taking, of course, priority over all else. So this is not a cost. I mean, transport's a cost, housing is a cost, health is a cost, but they're all industries. And this is the biggest and most important, fastest growing. Now, while there are other technologies being brought to bear, glorious technologies across the spectrum of biomedical engineering and chemistry, etc., but the fundamental underpinning of this revolution is personal genomic information. And there's little doubt, and I get very little dispute on this statement, that ultimately, and probably over the next 2 decades, all consenting members of our community will have their genome sequenced and incorporated into their personal medical records and into their healthcare. Amalgamation of this information with rich clinical records, including data from imaging and high-resolution molecular phenotyping, etc., will create an unprecedented multi-dimensional ecology. That data ecology can be mined for biomedical discovery and for better management of medical systems and resource allocation. This will have a transformational effect on health, both individually and systemically, with enormous implications for national economies and huge opportunities for countries like Australia if they're nimble enough and for the development of innovative industries. Now, we were lucky enough a few years ago now, 3 years ago, to be one of the first 3 centres in the world to acquire the technology to sequence human genomes for the base cost of $1,000 US. We've done over 16,000, doing well over 1,000 a month. That's, of course, supported by an incredibly large and sophisticated and costly computing infrastructure, as well as a multidisciplinary team of over 70 people, not just lab scientists, but bioinformaticians, software engineers, and genetic pathologists, etc. Which is my first editorial point here, talking about the role of philanthropy. It's come up in the last session. We would never have achieved this through government agencies because, and the point I want to make to you is that philanthropy, whether it's through the Coulter Foundation or through, in our case, the Kinghorn Foundation, enables innovative enterprises to flourish and move quickly. Peer review is overrated and in fact is a dead weight on innovation because at best, and when it's working well, it optimises the orthodox, but historically and evidentially it's very poor at identifying the transformative. Books have been written about this recently in the UK, looking at the history of innovation over the last 2 centuries. In any case, moving on, we've established a company called Genome.one. That's its URL. Recommend, if you've got nothing better to do, just to dial in to the browser, Genome.one, and go and have a navigate. The opportunities, and I have to move quickly, in genetic disease, cancer and health management. I'm going to give you quick vignettes of these just to give you a feeling for the power and potential of this area. The first example is just a Just So story, but it's one of ours from the local children's hospital here in Randwick. A little boy named Alan who was chronically in intensive care, bleeding to death internally. That's him lying with his mother who had to sleep with him because he was in intensive care so often. Nobody knew what was wrong with him except that he had no platelets and he was bleeding to death, and nobody knew whether he'd survive from day to day or week to week. We sequenced him, we discovered what the problem was. It was missing a particular gene and protein in the immune system, strange form of autoimmunity. With that molecular knowledge, we were able to identify that a drug called abatacept, which had been developed for other reasons in transplantation, might work. Emergency ethical approval because the drug hadn't been safety tested in children. 4 weeks later, he left the hospital, and that's him now. Now, these stories are very powerful for the community, but it also illustrates that even these exceptional cases, because not all cases are successfully treated to this level, can have major effects on health economics, and the savings from this child alone would probably justify the program. And I can say the English National Health Service has just introduced whole genome sequencing as the standard of care for all children born with serious undiagnosed disabilities. And here in New South Wales, we're discussing that actively with the Health Department. So disease diagnostics is a complex process. You have to go not from a clinical request on the top left there to a clinical report in the top right, but in the middle there's a whole range of pre-test counselling, the sequencing itself, the analytics are huge, and then the post-analytical processes. To do this, we've developed new software. This is software which will take a whole genome sequence and produce a ranked list of predicted protein variants for clinician assessment, where they take over the analysis and the treatment in a few minutes. We've also established the country's first genomics medicine clinic at the adjacent St Vincent's Hospital, where people who are undergoing these whole genome tests can get appropriate advice and counselling. We've developed new precision health applications, the patient archive system platform, because we realised that, and as I'll make a point again in a moment, genomic data is sterile without clinical and phenotypic data, but most of the data in electronic health records is free text from physicians, and we've now worked out a new platform which actually automatically converts clinicians' records into machine-readable ontology, so artificial intelligence and machine learning can go to work on it. We've also developed, and this is part of the social revolution in this space, self-phenotyping module for this software, and we've partnered with Sanford Health in the United States, one of the biggest HMOs there, to develop this further for both the American and markets, and they've invested very heavily in this in collaboration with us. We're also building, and this will have to be done for the public good at national level ultimately, but we're developing the prototypes for matched genome-phenome databases that will scale to millions of individuals. Of course, ultimately, we'll have essentially every Australian citizen in this country sitting in this database. And that's work we're doing with the Australian Digital Health Agency and others. Now, the mistake that's being made often in the evolution of this is to see genomics as simply a diagnostic test, more comprehensive one than perhaps the limited tests of the past. But in fact, the transformational effect of this is going to be its effect on whole-of-life healthcare in terms of its use in optimising drug choices and avoiding adverse drug reactions, as well as in disease predisposition screening. I just mentioned on pharmacogenomics that 7.6% of all hospital admissions in this country are due to adverse reactions to prescription medications, and many other medications are useless in a third to a half of all people who are prescribed them, simply because they have different rates of clearance for these drugs and therefore different half-lives in the system. And that's a huge area upside for gaining not only better treatment of patients, but better cost-effective investments by the community. The one case I'm going to give you, and thank you, Norman, for introducing this, is with cancer. And you were quoting data that suggests this is not productive, but I'm going to respectfully disagree with you. So we now know that cancer is a spectrum of disorders that are caused by a range of mutations. And those range of mutations pop up in all sorts of different contexts. So the mutation causes 15% of breast cancers, causes 8% of colon cancers, 3% of pancreatic cancers, and the drug Herceptin, which treats that subset of breast cancers, can be just as usefully applied to treating those subset of patients with that same mutation, these other cancers. In fact, the FDA, which is becoming nimble, I agree, Melissa, it's fantastic, have now done for the first time approving a drug based on its molecular target rather than on its disease condition. So I've just come back from a conference, big healthcare conference in Korea, where the latest data from the United States, particularly from Intermountain Health in Utah, which are really ahead of the curve and they can integrate all the healthcare costs, they reported a twofold, that's a 100% increase in survivability by using targeted treatments compared to controls on conventional treatments, and at the same time a 21%, that's their figure, a decrease in costs because they can integrate all the costs across the integrated healthcare system in Intermountain Health. We also, just very quickly, want to mention this because together with David Thomas and Mandy Ballinger at the Garvan and the National Cancer Institute in the United States, we've actually analysed individuals who were genomically predicted to be at high risk for cancer, largely focusing on P53, which is mutations, probably the most powerful cancer-causing gene. And by stratifying individuals by their genomic profile and then giving them high-resolution magnetic resonance imaging, because with these mutations, they're not tissue tropic like BRCA or Lynch syndrome, which is colon cancer. Most of the other mutations causing cancer are agnostic to tissue, so you don't know where it's going to pop up. But stratifying these individuals according to cancer risk and then subjecting them to magnetic resonance imaging, we and the NCI in the States discovered that 10% of those individuals already had cancers, the pre-symptomatic cancers they were not aware of. One individual had 2 separate cancers. And the important thing about this is that it's pre-symptomatic, pre-metastatic, and easily and cheaply curable by surgery. And, if you talk publicly, say, look, one of the things that will come out of genomes is to identify people, and these are all recessive mutations, so they sleep in pedigrees, they're not obvious. Say, well, look, regrettably, you're at high risk of cancer, but I don't want you to worry. I know you will, but what I do want you to do is come get a thorough checkup each year, and we'll pick it up early, and you'll be fine, and you'll survive. And I'll come back to the context of that in terms of insurance and the whole dynamics very quickly. So we've established now a personal health genomics program, which has just gone live a couple of months ago. We're now doing whole genome sequencing for wellness, not for illness, and this is the essential shift that's going to happen in healthcare. We're looking at 49 conditions, 230 genes, cancer risk genes, cardiac arrest genes, and also pharmacogenomic responses for 340 medications. And the amazing thing that's coming out of this is that most people do not at high elevated risk for heart disease or some for cancer, but nearly everybody has some medications they shouldn't take or that are useless to give them, and this is very, very useful information. I might just also say parenthetically, we've started sequencing people with complex diseases, with chronic diseases, and we're identifying the genetic causes of 30% of those straight up, and that's the first route to helping those people. So just to finish, this is going to create a new data ecology that's got clinical records, Internet of Things, millions of genomes. It's sterile without phenotypic information, but the ability, thanks Norman, is empowered by genomics. We're going to create a new multi-dimensional, excuse the spelling error there, data set that we can have orthogonal queries independently of the reasons for collecting the data in the first place, which is why the English are investing in not only 100,000, about, I think, to announce a 1 million genomes project in England. So we have a new data ecology. We have not only clinical records, genome sequencing, genotype-phenotype databases go straight into diagnosis, prognosis, new knowledge which feeds back, of course, and into population health. This will be a very important part of the ecology, all the mobile devices, and in the sub-tissue implantable devices being developed on the west coast of the United States, which I think will sweep into most medical applications very quickly. We need machine learning and data analytics, and we've partnered with Svetha Venkatesh at Deakin to advance this along, and also with Australian startup Xenome to guarantee new structures for protecting the data, the privacy and provenance of these things. My final comment is that that I think this is going to change not only the healthcare landscape, but all the structures, including of insurance, and I'm convinced that the life insurance industry will take over the private health insurance industry because their model is wellness, not payment at the point of crisis for illness. Thank you very much.